Hello, Math 140 students. We are going to pick up on page 10, section 2.4. This is all about using that formula, distance is equal to rate times time. So here, we're going to keep seeing this formula keep popping up and refer to it as the motion applications. So whenever we're thinking about motion, whenever we have a distance, a rate, and a time, this is all talking about the same thing. So one formula you will use often in algebra and in everyday life is the formula for distance traveled by an object moving at a constant rate. Rate is equivalent to speed. The basic idea of any rate may already be familiar to you. So here's our warm-up. It says, do you know what distance you travel if you drive at a steady rate of 60 miles per hour for 2 hours? Well, you know that you're going to be using your formula where distance is equal to rate times time. So we just have to identify what we have. So here you have your rate as 60 miles per hour. So I know that 60 is going to represent my rate. So I have that R is equal to 60. And I also have my time. So I have hours, which represents my time, which is going to be 2. So I have my time is equal to 2. So now if I have that formula, distance is equal to rate times time, I'm just going to be plugging in my values. So for distance, I don't know what that is, but for my rate, I have 60, and for my time, I have 2. So I have 60 times 2, which is 120. So the distance that you travel is 120 miles. The next example says, Javier is planning to drive from his house in San Diego to visit his grandma in Sacramento, a distance of 520 miles. If he can drive at a steady 65 miles per hour, how many hours will the trip take? So let's think about that. He is starting out in San Diego. Since it says from San Diego, so that's where you start. Then he needs to travel a distance. So let's think of this as a road. And he's traveling on this road for a total distance of 520 miles. And that is your distance. And it says he wants to visit his grandma in Sacramento. So where you want to end up is in Sacramento. Now it says that I have a rate, right? A steady 65 miles per hour. So that is going to be my rate. So R is equal to 65. How many hours will the trip take? So you know that you're looking at your distance is equal to rate times time. So the distance that you have is 520. The rate that you had, remember, was 65. And the time is what you're trying to figure out. So to get the time by itself, I'm going to divide both sides by 65. So that 520 divided by 65 gives me 8. Since T represents my time, I will have my total time of 8 hours. And that would be my final answer. So number 2 reads, Yesenia is 168 miles from Chicago. She needs to be in Chicago in 3 hours. At what rate does she need to drive? So since it says that she needs to be in Chicago, that is where you're driving to. So you want to get to Chicago. And she is a total of 168 miles from Chicago. So you don't know where she is, but you do know that wherever that she is to get to Chicago is going to be 168 for your total distance traveled. And it also gives you your hours, so that would be your time. So your t is equal to 3. So if you have the formula that distance is equal to rate times time, well, the distance was 168 that Yesenia had to travel. Your rate you don't know, and the time that's given to you is 3. So your equation is really 168 times is equal to 3 times t. So divide by 3 on each side. 168 divided by 3 gives you 56. You have your total distance is equal to rate times time. So here, your distance is that 168. Your rate, you don't know what that is. What rate does she drive at? So your rate is unknown. So that's what you're trying to solve for. And the t that you're plugging in is 3 for time. So you really have 168 is equal to 3 times your r. And to get the r by itself, divide by 3 on both sides. So that 168 divided by 3 is going to give you 56. So your rate is 56 miles per hour. So that is how fast you're going to be driving. Now for my practice problems, it says that Lucas drove for 4 and 6 hours at 60 miles per hour. How much distance did she travel? And I guess if I'm talking about Lucas, that should really be a he. That's a misspelling, so I apologize for that. Lucas is our tutor here, so we know who Lucas is. So we have that distance is equal to rate times time. So I have my amount of hours. That gives me my time. So I know that my t is equal to 4 and 5/6. And if I wanted to change it to an improper fraction, so right now this is a mixed fraction. And we can definitely change this into an improper fraction. And that usually helps us with our multiplication. So I still know I'm going to have my denominator of 6. So I'm going to have 4 times 6. And I'm going to add that numerator, so plus 5. So 4 times 6 plus 5 gives me a 29. So I know that my time is equal to 29 over 6. I also have my 60 miles per hour. That is my rate. So that tells me that r is equal to 60. So I'm going to plug in my values here. The distance is I don't know. I'm trying to figure that out. But I know that the rate that was given to me was 60. Now I'm going to multiply that by my time. Now I'm going to multiply or plug in the improper fraction, 29 over 6. And if I bring up my calculator, I'm going to have 60, and I'm multiplying it by that fraction, so alpha y equals on the TI-84 plus calculator, and my numerator is 29, and the denominator is 6. And I end up getting 290. So I know that the distance that he's going to travel is 290 miles. For number 2, it says Phil got a ride with his friend from Denver to Las Vegas, a distance of 750 miles. If the trip took 10 hours, how fast was the friend driving? Well, you know that you start out in Denver, and you end up in Las Vegas. Since you are from Denver and to Las Vegas. And the total distance here is 750. And you have your amount of time. So t is equal to 10. So I know if I'm using the formula, distance is equal to rate times time, then I plug in that 750 for my distance. The rate is what I'm trying to figure out, and the time that I have is 10 hours. So that 750 is equal to 10 times r. So now I end up getting that 75 is equal to my r. So 75 miles per hour is your rate. What we want to do next is solve for the variable in each equation. So for number 1, it's asking us to solve for h. So here I have h there. Now I have a is equal to a 1/2 times my base times my height. Well, to get rid of that 1/2, I can multiply by the reciprocal, which is 2 over 1, or just 2. So I end up with 2a is equal to my base times my height, since multiplying a fraction by the reciprocal cancels it out. To get the h by itself, remember, I still want to get that isolated, then I divide by that coefficient. Even if it's another variable, you can divide that out. So that 2a divided by b is equal to my h value. Now for number 2, I have interest is equal to principal times rate times time. I is equal to PRT, or some mathematicians like to say, I like to party, right? PRT. So my goal is to get the P by itself. I is equal to P times my R times my T. When I write it this way, I can see the space represents your multiplication. So to undo multiplication, you divide. So you're going to multiply by an R and a T. So you end up with I over R times T is equal to your P value. Now for number 3, my goal is to solve for y. 3x plus 2y is equal to 18. That is the equation that they gave me. So what's happening with that y? Well, it's being multiplied by 2, and that 3x is being added to it. Well, you want to do the thing that's farthest away. So you want to subtract the 3x so that it can cancel out, since you have a positive 3x and a negative 3x. So that 2y is equal to a negative 3x plus 18. From here, I want to divide by 2 on each side, so that y is equal to a negative 3/2 x plus 9. And I have my formula and I have my values. So I have my distance is equal to my r times my t. The value for my distance is 175. The value for my rate is 70. So what I'm trying to figure out is my time. So divide both sides by 70. 175 divided by 70 gives me 2.5. If you wanted that as a fraction, you could have done that on your calculator as well. So what I would have done is I would have entered in my numerator as 175 and my denominator of 70. So 175 divided by 70. And it gives me my fraction of 5/2. So it just depends on whether or not your final answer is requested to you as a decimal or as a fraction that's simplified. So you really have to read the directions on how you should be stating your final answer. If I ask for a decimal or a fraction, you know how to do either. Now we have this challenge problem. We want to solve for this variable h. S is equal to 2 pi r squared plus 2 pi r h. Well, since h is here, you want to do what's farthest away on that side. So that would be that 2 pi r squared. So since it's addition, you want to subtract it. You can think of the equal sign as, the right-hand side of the equation and then the left-hand side of the equation. So on the right-hand side, I minused it. So on the left-hand side, I have to do the exact same thing. So I end up with s minus 2 pi r squared is equal to, and of course the opposites cancel, so you have that 2 pi rh. Now, since everything is being multiplied, you can divide. So divide by 2 pi r. And you end up with s minus 2 pi r squared over s, that denominator there is a 2 pi r. And since everything canceled from the numerator and the denominator, you're just left with that h. So now you have solved for h. Okay, so down below we have practice problems. It says isolate for the given variable. I want you, the student who is watching this video, to try these problems on your own. So go ahead and look at your device, whatever you're playing this on, press pause and really try to do the problems by yourself. And when you're done with each practice problem, then review the rest of this video. So I'm going to go ahead and press pause, and hopefully you guys work out those problems. So hopefully you guys have worked out these problems. So for number 1, my answer I got was y is equal to negative 2/3 x plus 4. For number 2, that answer is v divided by L times w is equal to my h. For number 3, I got the r, my rate, to be 64 miles per hour. For number 4, what was important about this one is that 5.2%, you have to change that percent into a decimal. And so every single percent is actually being divided by 100. So I divide by 100 and I get a 0.052. That's how I got my t value, my time, to be 2 hours. For number 5, what I did is that 5/9, instead of distributing inside the parentheses, I decided to multiply by the reciprocal so that it can cancel and make my math a little bit easier. So I get that f is equal to my 9/5 c plus 34. And that is the end of section 2.4.